Hello friends, in this session we will learn about entity relationship diagram, or more commonly used as ER diagram. So in this session 1 we will discuss about the basics of the ER diagrams. ER model. ER model is basically a tool for designing your database. While doing any project, the first step is information gathering, where we try to learn more about the project to understand the system. We gather the information and analyze it to make the understanding of the systems. Once we are able to get the system understanding, then we proceed for designing a database. So while designing a database, we need some tool. Before coming to the actual database, we first have to make a blueprint of it. So ER model is something that helps us to make a blueprint of our database that we are going to make for our project. So ER model is a tool basically that is used by the database designer with the help of the end users during the analysis phase. So we can say that ER model is used to construct a conceptual data model. ER model or entity relationship model is basically based on the two concepts, as the name suggests, entities and relationship. Entities is basically any object or a thing that we see in the real life. For example, Professor ABC or any course database systems. So we can say that entity, it can be a physical object or a conceptual object. The second component of ER model is relationship. Relationship is an association or an interactions between the entities. For example, one entity is Professor Ba, and one object I can say is any course database system. So the professor and the course is related with the relationship teaching. So if I make a statement, Professor Ba teaches the course database system, then teaches is a relationship that associates the two entities. So entities is any physical object, any real life thing, and the relationship is something that associates the two entities. So ER models, or sometimes we call it ER schemas, are represented by the ER diagram. With the ER diagrams, we are able to design our database. So in order to understand the ER diagrams, we have to understand some terms like attribute types, relationship types, degree of relationship, relationship cardinalities, and keys. These are the key terms that will be used in the ER diagrams, and it is very important to understand these terms. The first is attributes and its type. So we have different type of attributes like simple attributes, composite, single valued, multi-valued, stored attributes, and derived attributes. Simple attribute is an attribute that is composed of a single component, like a gender. For gender, the values can be a male and female. It's simple. Now how it is simple? Now it takes another attribute type, that is a composite, that is composed of multiple component. For example, name. When I say multiple component, means the name contains multiple. The name is basically contains multiple parts. It has multiple components. For example, name can be divided into first name, father's name, then the region name, or the first name, middle name, the last name. So it can be divided into the two parts or three parts. It has multiple components. But in case of the simple attribute, the gender has only one component. Then single valued attribute. Some attributes can only contain one values. For example, roll number. So roll number has exactly one value. We cannot enter two values for a roll numbers. The other is multi-valued attributes. Multi-valued attributes are the attributes which can contain multiple values. For example, hobby. Now to understand the single valued and multi-valued, if I ask for any student what is its roll number, then he or she will be only having a single roll number. He cannot have two roll numbers. But when I ask about his or her hobby, he may answer two hobbies, maybe sleeping, maybe reading, playing, traveling, driving. So it can have multiple values. So hobby is a multi-valued attribute, roll number is a single valued attribute. Then we have stored attributes. Stored attributes are the attributes whose values cannot be derived from the other attributes. Now for example, if I say single valued, composite attributes, simple attributes, these are all the stored attributes because these values cannot be derived from the other attributes. These are independent. So if I say the example of stored attribute, that is a DOB, date of birth. Now some attributes are basically can also be used to provide the values of some other attributes. For example, derived attributes. Now these attributes are the attributes which can be derived from the stored attributes. For example, age. If the date of birth is known for any person, we can calculate the age. So age is a derived attribute from the stored attribute, DOB. The next, ER diagram representation. So as it is the name shows, it's a diagram. So definitely we have some symbols, some defined symbol which have the specific meaning. So how to represent the ER diagram? First we have to understand the meaning of each symbol which we are going to use for ER diagrams. So we use the rectangular box for entity set. Entity set is represented by a rectangular box. Then the other is a relationship set, that is represented by a diamond shaped box. Then for attributes we are using the ellipse sign. Now this ellipse sign is used to represent the simple attributes, stored attributes, and single valued attributes. The derived attributes are represented by a dashed ellipse. For multi-valued attributes we are using the double ellipse. For key attributes we are using an ellipse with an underline. Then composite attributes are shown by an ellipse attached with a multiple ellipse. These have the defined symbol in the ER diagram. So while designing the ER diagram, we have to be very careful to use a defined symbol for a particular attribute. Now let's take an example. Let's say student is an entity and it has two attributes, student ID and the student name. Now here the student ID is a simple attribute. It is also single valued. And student name is a composite attribute because it is divided into the three components: first name, second name, and last name. So we are going to represent the student with these two attributes, with a simple attribute and the multi-valued attribute. We have to draw our figure like this as is shown in this diagram. This is a further extension of our same example student. So here student ID, as I have told you, that this is a simple attribute and also it is a single valued. And date of birth is an attribute, it's a stored attribute, and it has shown that it is driving a other attribute, that is age. So age is a derived attribute because the value of the age is actually derived from the date of birth. Then we have also attribute, that is a multi-valued attribute, GSM, because a student may have multiple mobile phones, so it is multi-valued. A student is having only one ID, so it is single valued. So these are the symbols which we are using in our ER diagram to represent the different type of attributes. Another example, we have employee. So we have name, address, birth date, salary. So address is a composite attribute. Then in the second part of this example, if employee, we need degrees also, then we have an attribute degrees. An employee can have multiple degrees, so we are showing the attribute with a doubled ellipse sign. Now if you see here, I have made here employee and the attribute name. So it's up to the design. If we are keeping what is the first name of the employee, this is okay. But if you are keeping the full name of the employee, then this is a multi-valued attribute, and we have to show the proper components of this attribute, like first name, second name, last name. Then relationship. As we discussed, that relationship is an association between the entities. It's a concept which states a link or relationship between the entities. So we have teacher as one entity, student is one entity, and they are related with the relationship teaches. So the teacher teaches the student. Then here comes the very important concept, is to understand the degree of relationship type. So we have unary, binary, and ternary. Now unary relationship is degree 1. Unary means 1, means the relationship of unary is the degree of unary relationship is 1. It is a relationship between the instances of the single entity type. So in the unary relationship, only one entity is involved. In the binary relationship, two entities are involved. In the ternary relationship, three entities are involved. So in this unary relationship is also called as recursive relationship, where the single entity is actually written to itself. For example, employee and relationship is manages. So if you look at any organization where we have the employees and we have the managers and staff. So if you see that manager of the of that particular organization is also the employee of that organization. So he is also in the employee category. So here we have the relationship employee and manages, because here all are employees, but maybe their designations are different. So only one entity is involved in this relationship, that is employee. This is a unary type relationship. Then we have binary relationship. Binary means two. So in this type of relationship, two entities are involved. In binary relationship is the most common relationship in the data modeling. In our ER diagrams, or normally when we do data modeling, we occur most of the time we see that we have more relationships are of binary type, that two entities are mostly associated with each other in compared to unary and ternary. So here if you see, we have one entity set employee, the other entity set is department, and they are related with each other, that employee works for the department. This is a unary relationship. Then we have ternary relationship. Ternary means 3. So for ternary relationship, the degree is 3. In this, it is a simultaneous relationship between the instances of the 3 entity types. So in this relationship, three entities are participating. As in this example, we have supplier, parts, and project, 3 entity sets. These are related with the supplier relationship. Then we have cardinality. This is a very important concept in ER diagram. It states the maximum number of relationship instances that an entity can participate in. So in relationship, we have seen that the two entities are associated with each other, but how they are actually participating in the relationship is to be identified or to be represented with the cardinality. Now here we can see that manager and department, these are the two separate entities and they are related with the relationship managers. So if we look at the cardinality, we have seen here that if you see at the entity relationship box, we have one digit 1, and also at the department side we have C1 digit 1 is written. So this is 1 to 1. That means that we have one manager for each department, or you can say for each department we have one manager. So the relationship is 1. Here the relationship is manages and the cardinality is 1 to 1. Another example, if you see, we have employee and department, they are related with works in. So you can see here, this is n is to 1. So here the meaning is that n employees can run in a single department, or you can say in one department we have n number of employees. In the third cardinality, you can see employee joins the project. That means this is m is to n cardinality. That any number of employees can work for n projects, or n projects can have m employees. Or you can see that one employee can work for multiple projects, and in one project there will be multiple employees. So this is very, very important to understand that how the relationship is associated between the two entities. This can be understood by cardinality. The other important terms in the ER diagram is the key. So an important constraint on the entities is a key. Key is an attribute or a group of attributes whose values can be used to uniquely identify individual entity in an entity set. So keys are the unique attributes within an entity. For example, in case of an employee, the employee may have attributes EID, name, address, age, and salary. So here if you see that each employee is having a unique ID. So EID is the key. Sometimes in an entity we can find that only a single attribute can be taken as a key, or sometimes there is no single attribute can be acted as a key. In that case, we can combine two attributes as a key. Then we have some notations to represent the cardinality in our ER diagrams. One is optional one, mandatory one, optional many, and mandatory many. Optional one means that the two entities are related with each other. If they are related, only one instance is only connected or associated. But in mandatory one, that means only one instance is only related. Optional many means there may be option, or maybe one is related or many related. What is mandatory many? That means multiple instances are mandatory be related. So these are the notations which can be used to represent the cardinality among the relationship. Now, for example, the person owns a bicycle, so it is shown optional one. That means the person may own or may not own. If it owns, then only maximum he can own one bicycle, not more than one. And the second example, mandatory one. Team has leader. That means team has exactly one leader, not more than one, not less than one, exactly one leader. Optional many means student register for courses. Then a student can register for one course, or they cannot register for any course, or they can register for many courses. Mandatory many means courses uses textbooks. Each course has to use many textbooks. So these are the notations which are used for presenting the cardinality in an ER diagram. In the next session, you can see how to map the ER diagram to relationship. Okay, meet you in next session.